Okay, so today we're talking about functions. So the common core topic is functions, building functions. So basically we are building functions from other functions, okay? And again, how do we know something's a function? Every x value will have exactly one y value paired to it. So one of the things we did is we looked at our parent functions. Our parent functions were our constant, our linear, our quadratic, our cubic, and our square root. So these are the functions we did in our reading. Okay. So what I want to do is this. Before I even start, everybody please write this down. Big star, okay? Big star, okay? Parentheses, okay? X plus C, all right? Write that down, okay? So, if something is on the inside, we talked about this yesterday, we're going to apply it today. It's on the inside, we move it horizontally, but the opposite way. Okay? Always. So, if something is on the inside, for example, -1, we're going to move it forward 1. Okay? -1, we're going to move it forward 1. -1, we're going to move it to the right 1. +2, we're going to move it back 2 or to the left 2. Okay? So if it's on the inside, we always go the opposite. If it is a +3, we're going to move it to the left 3. Okay? It's always the opposite. Okay? It zeroes it out. I'm going to show that. Great question. It really is a great question. Why would you do that? Yeah. Oh, man. It makes the very 0 point, doesn't it? Yeah, Cody, question. You didn't get a paper? yes. I'll have Isaac. Let's just leave that. Isaac, okay.
Instead of the...
You want to give that to Cody, please? Okay. So let's take a look at these, all right? So to start off with number 1, the parent function. It's a parabola, right? So it's going to have this shape, but we're going to take this shape and we're just going to move it up 2. So we're going to take our parabola right here and we're just going to go up 2. That's all we're going to do. So to graph x squared plus 2, its vertex, let's write the vertex down, is at 0, 2. 0 because there's nothing inside the x, right? There's nothing inside the x squared, so 0, 2, so we go 1, 2. And I'm going to graph the parabola using a t-table in my brain because we're smart. Over 1, up 1 because 1 squared is 1. Over 2, up 4 because 2 squared is 4. 1, 2, 3, 4. Over 3, up 9, but I'm kind of off my paper, right? And I know that if it's a parabola, it's symmetrical, so I'll put the other half of it on the other side. So I'd have a point here, I'd have a point here, and there, okay? How's that? Not bad? Thumbs up? Okay. Okay, example 2. It is still a parabola because of the x squared, okay? It's still a parabola, so here's my parent function for my parabola. We're going to take this shape and we're simply going to move it to 1, 0. So its vertex, is at 1, 0. So let's go to 1, 0. It's right there. And we'll do the same exact parabola. We're just going to do this parabola, but right there, right? So I do the t-table in my head because I go over 1. 1 squared is 1. Go back to the vertex. Go over 2. 2 squared is 4. 1, 2, 3, 4. Go back to the vertex. 1, 2, 3. 3 squared is 9. 4, 5, 6, 7, 8, 9. And of course it's symmetrical, so I'm going to put in the line of symmetry. It just sometimes helps me. But the line of symmetry goes through the vertex, right? So I'm going to flip it over the line of symmetry, so it's going to go over there. I'll put it here. And I'll put it there. And up there, okay? Alright, number 3 is also a parabola because of the square, right? It's got a square, so it's also a parabola. So our vertex is at positive 1, 2. Positive 1, 2, okay? Okay, John, I want to answer your question right now, okay? So when I graph the vertex at 1, 2, I'm at the very lowest point, all right? I mean, the vertex is definitely the bottom point, right? It's the very bottom point. So if I were to put 1 in for this, 1 minus 1 is 0. It just zeroes it out. Puts it at your bottom point. That's why it's the opposite, because that value zeroes this out, okay? And then I'm just going to do what I did. I've always said 1, 1. I'll go over 2. 2 squared is 1, 2, 3, 4. 9's probably up here somewhere. I'll just, throw it up there. Up 9, right? And then it has a line of symmetry, which I like to put in. Just helps me graph it, right? And I'm going to reflect the graph over the line of symmetry. So I'd put a point there and a point there and one way up there, okay? How am I doing? Thumbs up? Seem pretty easy? The biggest thing is to know that if it's on the inside, it's the opposite horizontal direction, okay? If you get that, then this is easy. Okay, example 4. Its vertex is at, same thing, a 1, 2, right? Because it's the opposite of the inside. It is also a parabola because of the x squared. Okay, it's got to be a parabola, x squared. The vertex is at 1, 2. So we got a 1, 2. It's right there. But this one's upside down. It's got a negative right there, okay? So it's negative on the outside. It's a flip over the x-axis because the y values become negative. Does that make sense? So it's just going to be upside down. So I'll still do my 1, 1, but I'll just do it upside down. 2, 1, 2, 3, 4. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll put it right there, okay? The line of symmetry, you don't have to put the line of symmetry in. Sometimes it just helps to flip it. If I put the line of symmetry in, you can see how it's just a reflection over the line of symmetry. And I'll just draw it in, okay? How am I doing? Thumbs up? Seem pretty easy? Okay. All right, example 5. It's like a square root graph, isn't it? Now, it doesn't really have a vertex, but it has an endpoint, okay? So if we move the endpoint around, then we'll just put this graph here. And the way I do this graph is I go 1, 1, I go 4, 2, I'll go 9, 3. Does that make sense? Because those are square root numbers. 1, 1, 4, 2, and 9, 3, okay? It is basically a sideways parabola, isn't it? Sure it is, but it's sideways. Okay, so its endpoint of this one is at 0, negative 3, okay? Because there's nothing inside the square, so that's 0, negative 3. So I go to 0, negative 3 is right down here. Okay. Now I'm going to do my 1, 1, my 4, 2, my 9, 3 from my endpoint. So I go 1, 1, and I go 1, 2, 3, 4, 2, because the square root of 4 is 2. I'm going to go over 4, 5, 6, 7, 8, 9. Square root of 9 is 3. There it is. Yeah, Will.
So the 3's a negative?
Yes.
Why aren't you going...
If it's in the inside, we do the opposite.
Oh,
Only. Does that make sense? But then the outside is just exactly, either pull it up or take it down, okay? Good question. Thanks for asking that, okay? On example 6, the endpoint is at negative 2, negative 3, okay? Because it is the opposite of the inside. So negative 2, negative 3 is there, right? And I'm going to do my same. 1, 1, 4, 2, 9, 3, right? So 1, 1, because the square root of 1 is 1, over 1, 2, 3, 4. Square root of 4 is 2. Go over 9, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. And we get this graph right here. Show me a thumbs up, sideways. How am I doing? Okay, a little bit like that. Okay, all right, good. Okay, ready to turn the page? Daniel, okay, here we go. All right, example 7. What is it? What kind of function is it? What kind of function is this one? It's a cube, okay? So how do I do a cube? Well, I think cube numbers, okay? So here's my cube. 0 cubed is 0, right? And 1 cubed is 1. 2 cubed, what's 2 cubed? 8. So I go up to 8, okay? Negative 1 cubed is negative 1, because negative 1 times negative 1 times negative 1. Negative 2 cubed is negative 8, because negative 2 times negative 2 times negative 2 is negative 8. So when I graph cubics, I'll go 1, 1, I'll go 2, 8. I'll go 1, negative 1, I'll go 2, negative 8 when I graph my cubic, okay? So, first of all, let's find it's not really a vertex, but it's kind of its center point. Its turning point would be at negative 3, 0, okay? So the turning point is really that point right there. See, it just turns around that one. So let's go to negative 3, 0. Right there. I probably should have made my graph a little different, but hey, that's the way it goes. So here's how I do cubics. I'll go 1, 1, I'll go 2, 8. I'll go 1, negative 1, I'll go negative 2, negative 8. I'll go 2, 1, 2, 3, 4, 5, 6, 7, 8's off the paper, who cares? Negative 1, negative 1, 1, 2, and 8's down here, okay? Okay, example 8. It's also a cubic, isn't it? So it's going to be, there's my parent function, it's going to be this one right here. Let's find its turning point, its middle point is at negative 3, 2. Opposite, right? I took negative 3, made it negative 3, didn't make it positive 3, made it negative 3, right? So let's go negative 3, 1, 2, 3, and 2, okay? So I'll do the same thing. I'll go 1, 1, I'll go 2, 8, right? I'll go negative 1, I'll go negative 2, negative 8, because I'm cubing these numbers. So 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8's up here. Negative 1, negative 1, negative 2, 1, 2, 3, 5, 6, 7, 8. Okay. And it turns right there. It's actually called an inflection point. Just in case you care, it's called an inflection point. I'll put that over here, okay? Inflection point, okay? It's where you go from like kind of slowing down to speeding up. That's what an inflection, kind of slowing down and speeding up again. In business, that's a good thing in business, wouldn't it? If you were a business owner and all of a sudden, you know, it gets kind of slow, but you open up a second restaurant and your business takes off, right? So in business, an inflection point is usually a very good thing. Okay? Now, this one, last two. What kind of graph is this? It's a square root, isn't it? Isn't that a square root graph? Okay, so now this time we have to write the function. So we're going to go f of x. Let's start with fx equals. And I'm going to go square root, okay? Just like that. Let's start right there. So we have to write the equation, okay? So it's definitely a square root graph. Square root of x, okay? Now, we had to go back to down 1, right? So go back to down 1, it's got to be the opposite, doesn't it? And then down 1. So I went back to down 1. There's my back to, which is opposite, and then down 1, okay? Last one. What kind of graph is this? It's an x squared. It's a parabola. So let's start off here. F of x equals, let's go parentheses squared, okay? Let's go parentheses squared, okay? Let's put the x here, okay? So, to get to the vertex, we have to go over 1, down 2, right? Over 1, down 2, so I'm going to go x minus 1 minus 2. And that is the function. Not bad, huh? Okay.